COEM? What is COEM? COEM stands for collapsed emptiness. This paper describes a Gedanken experiment, German, for a thought experiment. It is a speculative paper based on physical facts we observed while standing on the shoulders of giants. In other words, we started with the proven knowledge bases of real and accepted physics. Here are some blocks representing areas of proven real physics. We then made some intelligent assumptions by extrapolating. If these extrapolations meet each other, they can either eliminate, complement, or do not match. If they complement and make sense, we might have a new postulate, or even a newly discovered advanced physics base. Our COEM analysis proved that all our assumptions were leading to the same area. So, we might have some new hypothesis here. But there is not a shred of evidence yet that support this idea. We still need the physical proof by experiment and observation. Chapter 2. Introduction. What was there before the Big Bang? There was no Big Bang. What is outside the universe? Absolutely nothing. No space, no time, no particles, no energy. New evidence suggests the universe started growing in COEM from nothing with random quantum fluctuation events. To do this, three things happened. Random quantum fluctuation events without any cause. Sequestering of the positive and negative particles. Bubble formation, growing into subuniverses containing energy. While the COEM idea is purely speculative, the physics holds up, meaning there might be a chance it could be true. In this paper, we are going to explain this. This is my new theory describing the structure of the universe. These are assumptions based on a combination of proven and accepted observations. The space between the galaxies and stars is a vacuum. Let us do a Gedanken experiment, German for thought experiment. The vacuum has still space-time, and occasionally a hydrogen or helium molecule, here and there. There is a difference if, referring to the emptiness of outer space, between the galaxies, or COEM, collapsed emptiness, outside the universe. COEM, in contrast, has no space-time, or no mass, or any molecules of any kind. This might be a little difficult to imagine. Chapter 3. Random Quantum Fluctuation Events. COEM is unstable, and has RQFE, acronym for Random Quantum Fluctuation Event. These random quantum fluctuation events are vibrating emptiness or nothingness. Another thing that is difficult to imagine. You may imagine something similar like the vibrations in string theory. These random quantum fluctuation events grow and shrink like a sine wave, and last a very short instant of Planck space-time 10 to the minus 34 seconds. These are space-time events in COEM. You may imagine the sine wave chopped in 6 parts with sections of 60 angular degrees each. Each section produces a separate space-time continuum with unique characteristics. Most of the random quantum fluctuation events created collapse back into COEM. But a certain small percentage will stay separated to be sequestered into space bubbles or foam. These random quantum fluctuation events section will accumulate in one of the 6 bubble types, 3 positive and 3 negative. Let us start with imagining a vibrating string in COEM. Remember, there is no space and time in COEM. The vibrating string is a random quantum fluctuation event. Now, this random quantum fluctuation event creates space and time in COEM. Now there is space and time created. Chapter 4. Subuniverses. Let us cut this string up in 6 segments, 3 positive and 3 negative. These segments are like 60-degree wedges of a pipe. The 6 segments are sequestered and kept separated in bubbles that will form the 6 subuniverses. The 6 subuniverses superpose each other into one final universe of volume. The particles exist in the same space. Like photons, they can be superposed and occupy the same space. These 6 different types of bubbles are the seeds for the 6 subuniverses. They will grow to like our subuniverse to a radius of 13.7 billion light-years. The diameter of space of our universe can even expand to 92 billion light-years due to inflation. The volume of our universe can also increase or shrink due to the ratio of incoming and outgoing particles. Are the number of subuniverses restricted to 6? Probably not. It could be that there are more than 6 subuniverses. We may never find out. Chapter 5. Dark Matter. The reason we think it is most likely that there are 6 subuniverses is that there is 5 times more gravitational pull on the galaxies. This additional gravitational attraction is referred to as dark matter. The matter that creates this additional attraction is invisible to us. It is pure speculation that we came up with the assumption that there are a total of 6 subuniverses, and that we occupy one of them and that one is the only one visible to us. The 2 are elements that will appear initially right after the quantum inversion warp are the space-time and the matter-energy. How did these 2 elements appear? They are part of the random quantum fluctuation event process, and are reset through random evolutionary trial and error reject or select to the correct relations of the constants to each other. Element number 1 is space-time. If time increases, then space shrinks. Created out of nothing with random quantum fluctuation event and can collapse back into nothingness again. Element number 2 is matter-energy. Energy is convertible into matter, and vice versa, and creates the forces. E equals mc square, Einstein. Forces are gravity, Higgs boson fields, and 3 other forces, electromagnetic, weak and strong nuclear force.